Lesson 4.1, Graphing Equations in Slope-Intercept Form. Our objective today is to write and graph linear equations in slope-intercept form and model real-world data with equations in slope-intercept form. Our standards from Algebra 1 are 2.2, 4.1, and 4.2. What we are doing here is we're going to concentrate a lot today on slope-intercept form, which you guys should already be familiar with that. Let me turn that off. You should already be familiar with that. So slope-intercept form, y equals mx plus b. The m, or the number in front of x, is always your slope. The b, the plain constant term at the end, is always your y-intercept, where it crosses the y-axis. So we're going to draw on some things that we've already done in the past. And we're going to use this information today that will help us throughout the rest of the chapter in using not only standard form, but slope-intercept form, and then we'll find out later this week there's a form for an equation called point-slope form. So we start off very simple, just like we did when we did this in enrichment. They literally give you the slope and the intercept, and they say, hey, write this in slope-intercept form. So that, it doesn't get any easier than that. So example A, slope is 3, y-intercept is -2. What in the world would the equation be for that? Josh? 3 what? 3x minus 2. That is really all we're looking for here at the beginning. You plug in the number for slope in front of x, you put your y-intercept at the end, and you're good to go. Okay, example B, slope's -1/2, y-intercept's 4. Jared, what would that one be?
Y equals -1/2 x plus 4.
Y equals -1/2 x plus 4. Okay, well, the next one looks a little interesting. Slope is 0, y-intercept's -3. Ben, what would that look like? Y equals -3. Because if your slope is 0, then 0 times x, well, 0 times anything 0 and it'd fall out. So there's no need to write it. So y equals -3 would be it. Anytime you have an equation where there's a y only, you know it's a 0 slope, and 0 fun at perfect north would result in what kind of line for us? Do you remember? What does it look like? Yeah, definitely horizontal, flat, 0 fun. Okay, that's part of what you have to do. Now, I did notice that there was also on the homework, which we'll talk about here in just a minute, they gave you a couple of problems. Let me just kind of jump to it here really quick so you can see it. These right here, 5, 6, and 7, okay? It says write the equation in the slope-intercept form. You need to deduct from the graph the slope, which we've already done in chapter 3. You count rise over run from one point to the next. You find your slope that way. And then the y-intercept. How do you figure out what number is your y-intercept, Ethan?
You look at where it crosses the y.
Yeah. So notice that on the first 4 problems, they do what we just did in our examples. They literally give you the slope and y-intercept. On these, you're going to have to figure out what they are. So you're going to look for your y-intercept there and come up with that value. And then you take the points that you've got on here, and you're going to count your rise over your run, okay, that kind of thing, and you'll have to figure out the slope and the y-intercept on your own. All right, so that's the couple things there, but I don't have an example in the notes of that. So you'll just pick off the slope and the y-intercept from the graph to write it. All right, now this next part, we're going to graph using slope-intercept form, and basically what you do is you graph the y-intercept. You start with that guy, and then you look at your equation, you find the slope. You make it a fraction if it's not already, because you need a rise and a run from your y-intercept. So you always make it a rise over a run. If it's not already a fraction, you just put it over 1. You rise that many steps up and you run right. Now, sometimes you don't always get to do that. If it's negative, remember to fall and run right. And then I think we've talked about this enough that yeah, it's great to always run right, not get confused, but sometimes if you run out of graph, you might have to do the opposite direction, and we'll talk about that if that comes along here. So let's look at this first one. Graph y equals 3x minus 2. So what we're going to do here is we're going to start out by looking at the y-intercept, which is at negative 2. So along your y-axis, you put your first point at negative 2, just like that. You look for your slope, and in this graph, or this equation, I'm sorry, the slope is what? What is it from that equation? 3. Is it already a fraction? Definitely not. Put it over 1. And I always kind of like to do this. Out in front, I like to write rise and run, because it tells me exactly what to do. So from that point, I already have graphed. I'm going to rise up 3, 1, 2, 3, and run 1. So it'd be right there. And now I'm ready to graph a line. Yeah, that was fun. Okay, so it would be like that. Alright, and make sure you definitely put arrows on the end. That one would be really, really steep, but when it is a whole number like that, it is going to be really, really steep. Okay, so that is graphing using slope-intercept form. Does anybody have questions about that? Alright, let's look at the next one then. I probably have some variations here of what could happen. Okay, so E, graph y equals 1/2 x plus 4. So I start out where? Where am I going to start out on this one? 4. Start out on 4. Okay, and my slope is what? 1/2. So if I put my rise over run out in front of that thing, that means I rise 1, run 2. Put my line in. And you know, if you really want to make your line straight, I'm using the line option on here so it makes it straight, or else you know my lines wouldn't be that straight. You can always do rise 1, run 2 till you're out of the graph and then use a straight edge, or even without one. By doing so many points like that, it makes your line just a little bit straighter. So you can continue with your rise over run more than just 2 points if you want to. That'd be probably better. Okay, questions about that? So, graph y equals negative 1/2 x plus 1. So again, I'm just going through some variations. I'm going to do F again because somehow the recording got turned off. I'm not sure if it got this one or not. So I'm going to go ahead and do y equals negative 1/2 x plus 1 again. Y-intercept of 1. And since it has negative 1/2, that's usually your rise over your run. But since it's negative, we would fall 1, run 2. And I would continue doing that all the way throughout the graph. And instead of falling 1, run 2, if I ran out of graph in one direction or the other and I needed to make adjustments, I could rise 1 and go 2 to the left. As long as I have one negative direction, that would be correct. If it has a negative slope, just remember that the line needs to be going downhill. And because I put so many points in, I didn't have to use the straight line function. I did pretty well without it. So the more points you can put in, probably the better off you're going to be. So that is y equals negative 1/2 x plus 1. Make sure your line's going downhill when it's like that. Okay, the next one, example G, it says graph y equals negative 3. So I think that was just like the one we looked at a minute ago. When there is no x term, that means that the number in front of x had to be what? 0. That means that the slope has to be 0. And when we're at perfect north slopes, when you have a 0 fun slope, it is completely horizontal. 0 fun to go skiing there. So y equals negative 3 just means that every y is negative 3. Plus, we already know it's going to be horizontal. So you go down there to negative 3, and it would be this line right here. That's the line of y equals negative 3. It's got to be a 0 slope because the x fell out. And every y is negative 3. That is a horizontal line when the slope is 0. Just the opposite of that is when there's only an x. Okay, when there's only an x, it's the opposite kind of slope from 0. What's the opposite kind of slope from 0 that we've talked about at perfect north? What's the opposite one? Somebody that hasn't answered yet today. Olivia, what is it? It's undefined. And when it's an undefined, we've said it's a no. So, oh no, all the way down. Okay, it's undefined slope when there's no y. Okay, and it means it's vertical. So it says every x is 2. That's what it's telling you. Every x is 2. So it would be this one right here. It'd be a vertical line through x is 2. Now, I want to mention something about that. Since it's a vertical line, it is the only line there is that is not a function. Remember when we talked about functions way back and we did the vertical line test? If it touched a graph more than 1 point at a time, well, if that's a vertical line, it definitely fails the vertical line test because every point is on that line. So it is not a function when it's like that. All right, are there any questions? You might have to write some equations. You might have to graph some equations. Real world data, they're going to give you some information about it where you have a y-intercept, that means the starting point, a stationary point, and then the rate would be the slope, a rise over run.